TechDaily.ai, your source for technical information. This podcast is sponsored by StoneFly, your trusted solution provider and advisor in enterprise storage, backup, disaster recovery, hyperconverged VMware, Hyper-V, Proxmox cluster, AI servers, SA365, a turnkey security appliance, and public and private cloud. Check out stonefly.com or email your project requirements to sales@stonefly.com.
Welcome to this deep dive. Today we're looking at something really fundamental, the C++ programming language.
Yeah.
Its creation, why it's still so relevant. It's kind of behind the scenes for a lot of tech.
It really is. And to get why C++ came about, you really have to rewind a bit. Think about early computing.
Right.
Programming was, well, it's very close to the metal, talking directly to the hardware.
So like super specific instructions for each type of computer.
Exactly. You had ultimate control. Yeah. But it was incredibly difficult, required deep, deep knowledge of the specific machine you were working on.
Sounds tedious. Not very portable.
Not at all. Every new machine, basically you were almost starting from scratch or doing major rewrites at least. Okay, so very specialized, hard to transfer skills or code, like trying to, build a house by chipping the stones yourself every time.
That's a good way to put it. So as computers got more powerful and the problems got bigger, people realized we need something more human-friendly.
Easier ways to tell the computer what to do.
Right, which led to languages for specific jobs, like Fortran. That was huge for science and engineering, made expressing math formulas much more natural.
Okay, Fortran for science.
And then you had COBOL. That was all about business data, managing big records and files, different tools for different tasks.
So specialized tools, but how did we get from those specific languages to something more general purpose, something that felt a bit more like modeling the real world?
Well, that really brings us to some key work done in Norway, actually, back in the 60s by Ole Johan Dahl and Kristen Nygaard.
Okay.
They essentially asked, can we make a language that lets us represent real-world things directly in the code? Make it more intuitive.
And their answer was?
Their answer was Simula.
Simula. Not a name most people know today, I guess. What was its big idea?
The absolute key innovation in Simula was the class.
Yeah.
You can think of a class as like a blueprint.
A blueprint.
Yeah, a blueprint for creating objects. So say you're simulating traffic. You could have a car class. It defines what a car is: speed, color, position, and what it does: accelerate, brake.
Ah, I see. So you define the carness once.
Exactly. Or for a business app, a customer class with name, address, purchase history.
Yeah.
Or even abstract things like a matrix class in math, defining how matrices work. It let programmers think at a higher level.
Right. Instead of just juggling raw numbers and bits of text, you're working with these concepts, these software objects.
Precisely. And Simula took it further. It introduced relationships between classes. Inheritance.
Inheritance.
Yeah, they use this great example, a fire engine. It is a kind of truck, right? And a truck is a kind of vehicle.
Okay, so like categories and subcategories.
Yeah, exactly.
Yeah.
This hierarchy, where specific classes get features from more general ones, that's fundamental to what we now call object-oriented programming, OP.
OP, right.
It's also tied to this idea of data abstraction, focusing on what an object does, not the messy details of how.
Okay, so we've journeyed from direct hardware coding through specific languages like Fortran and COBOL to Simula, bringing in classes, objects, OOP, a much more abstract way of thinking. So where does C++ fit into this picture? What problem was it trying to solve?
Well, C++ really emerged to bridge a gap. Simula's way of organizing things, modeling concepts, that was powerful for complex software.
But
Performance hit.
often, yeah. Those high-level abstractions could slow things down. The core idea behind C++ Dare, driven by Bjarne Stroustrup at Bell Labs, was to grab those great abstraction ideas from Simula.
The classes, the OP.
Right, and combine them with the raw speed and low-level access of the C language. C was already known for being efficient close to the hardware. It was developed by Dennis Ritchie, also at Bell Labs. So it was trying to be the best of both worlds. Get that nice, structured, object-oriented way of programming, but without giving up the performance needed for really demanding stuff.
That's exactly it. Having your cake and eating it too, programming style. The real magic, the key innovation, was making it possible to have classes like Simula, but have the compiler generate code that ran essentially as fast as C code.
Wow. Okay. That sounds incredibly useful.
It really was. That combination, high-level abstraction plus low-level efficiency, filled a huge need.
So C++ comes along, this hybrid powerhouse. I imagine it found its place pretty quickly then. Where did it really shine?
Oh, absolutely. Its real strength, the reason it's endured, is providing efficient abstractions. That makes it perfect for infrastructure software.
Infrastructure, like the plumbing of the digital world.
Kind of, yeah. The fundamental systems everything else relies on.
Okay, give me some examples. Where is that efficiency just non-negotiable?
Well, operating systems are a prime example. Your Windows, your Mac OS, Linux, they have to manage the hardware processor, memory, disks super efficiently. C++ lets you get close to the hardware when you need to.
Right. Managing resources directly.
Exactly. Or think about real-time systems. Things where delays are critical, like the control systems in a modern car's braking system, or flight controls in a plane. Milliseconds matter. C++ delivers that performance.
Okay, critical systems. Makes sense.
Even your smartphone. A lot of the low-level system software, the stuff managing the hardware, letting apps run side by side, chances are a lot of that is C++ vein.
So when you're really close to the hardware, performance is just essential.
It's paramount. And there's another critical factor for infrastructure, stability.
Stability, meaning it just has to work reliably for a long time.
For a very long time, often. Think about, say, the software running big IDM mainframes. Those things might run continuously for years. Or embedded software in industrial gear, like fuel injectors in huge marine engines.
Wow, years.
Decades, sometimes. Even web browsers, which see more every day. They need to be incredibly stable, handling all sorts of weird websites and complex apps day in, day out, without crashing constantly.
That kind of longevity, why is that so important for this kind of software?
Because rewriting that fundamental code is hugely expensive and disruptive. Imagine trying to replace the core operating system of, say, the entire banking system every 5 years.
Chaos, complete chaos.
Right. The compatibility nightmares, the sheer manpower. It's astronomical. C++ has been around for, what, roughly 3 decades now? More, depending on how you count.
Okay.
That history, that longevity provides a massive amount of stability and trust. You generally don't build critical, long-lasting infrastructure on a language that might just disappear or change radically next year. That forces painful, expensive rewrites.
So its age and the fact it's so widely used actually become major strengths for these kinds of applications. Stability through, well, being established.
Precisely. The fact that C++ code written, back in the 90s or even 80s in some cases, can often still be compiled and run today. That's incredibly valuable for maintaining these critical systems. You don't want to rewrite them if you don't have to.
You always hear that C++ is, well, complicated. Maybe too complicated. Is that fair?
It is fair, yeah. The problem of C++ complexity is definitely a common point. But the reason why it's complex is actually deeply linked to that stability we just talked about.
How so?
To avoid breaking all that existing code, decades of it, remember, some going way back, C++ has had to evolve very carefully. It maintains backward compatibility.
So it has to keep supporting the old ways of doing things even as new features are added.
Exactly. That commitment to not breaking older systems, which could be running critical infrastructure, well, it inevitably adds layers. Features accumulate. The language grows.
So the complexity isn't just for fun. It's kind of the price you pay for ensuring that massive existing software base doesn't suddenly crumble.
That's a very good way to put it. Supporting that vast ecosystem of C and C++ code, much of it absolutely mission-critical, it forces a certain complexity onto the language itself. It's a trade-off. Introduce new stuff, but don't break the old stuff. It's a tough balancing act.
Okay, let me try and wrap my head around this. We started way back, coding directly on hardware, tough, specialized. Then came languages like Fortran and COBOL for specific domains. Then Simula blew things open with classes, objects, this more abstract, real-world modeling approach.
Right.
Then C++ steps in, tries to merge Simula's smart abstractions with C's raw speed and efficiency. And because it nailed that combination, it became the go-to for building foundational software operating systems, control systems, things needing performance and rock-solid stability over decades.
A perfect summary.
And the complexity people talk about, it's largely a result of its own success, needing to stay compatible with all that crucial code written over its long history.
Couldn't have said it better myself. Its whole story is about that constant push and pull, making programmers' lives easier with abstraction, while still meeting those brutal demands of performance and stability for the systems that, really make everything else work.
It really is fascinating. You use technology every day, but digging into something like C++, it gives you a totally different appreciation for what's going on under the hood. It's often invisible, but absolutely vital.
It really is. And maybe that's something for you, the listener, to think about. Consider all those layers of tech you touch daily. Your phone, the internet itself. How much of it relies on these foundational languages like C++ pull humming away reliably, even with all their intricacies? It's kind of amazing, really. Shows the power of solid engineering, even when it gets complicated.
TechDaily.ai, your source for technical information. This podcast is sponsored by StoneFly, your trusted solution provider and advisor in enterprise storage, backup, disaster recovery, hyper-converged in VMware, Hyper-V, Proxmox cluster, AI servers, SA365, a turnkey security appliance, and public and private cloud. Check out stonefly.com or email your project requirements to sales@stonefly.com.